Hi students, and welcome to all of you in my 6th lecture of module 2. Myself Tanmoy Datto, Assistant Professor, Department of Chemistry, JS College of Engineering, Kolani. In the previous class we discussed about the basic concept of the cell, but today we will discuss about the few topics which are very much important in the electrochemistry. Like first of all, today we'll discuss about the EMF. Okay, so what is the EMF we'll discuss today. Secondly, we'll discuss today that what is the cell potential. Okay, so what is the cell potential, this also we'll discuss today. Okay, then today we'll discuss about the that how we can represent a cell. Okay, so how we can represent a cell, that also we will discuss today. And the most important topic of today's class is the Nernst equation. Okay, so this is the most important topic of the today's class, that is, this is the Nernst equation. So with the Nernst equation we also will solve some numerical problems. Okay, so we will also solve some kinds of numerical problems. Okay, so these are the today's topic. So one by one we have to discuss, because these all the topics are very important for the conceptual purpose and as well as for your exam purpose. Okay, so without further delay, let's start the class. So first of all, in the previous class I discussed with you that there is some kinds of electrochemical cell. Okay, there is some kinds of electrochemical cell, and I explained with you that zinc copper electrochemical cell. Okay, just try to remember, there is a zinc copper electrochemical cell, but this cell, there is a particular way by which we can represent the cell. So what is the procedure by which we can represent the cell? So we can represent the cell in the simple way. For example, what was the reaction? You know, if you remember that in the anode, zinc was oxidized. It was oxidized, that zinc to Zn 2 plus 2e. So zinc to Zn 2 plus 2e, it is the example of the oxidation. It is the example of the oxidation. And copper 2 plus plus 2e, it is reduced to the copper. So this is the example of the reduction reaction. Okay, so first one is the zinc to Zn 2 plus, it is the example of the oxidation reaction, and another is the copper 2 plus to copper, this is the example of the reduction reaction. So what is the procedure by which we can represent the electrochemical cell? So first of all, in the left hand side you have to represent the anode. Anode means where oxidation occur in the particular way, that means how oxidation occur. So if we represent the cell, then it will be, you know, zinc to Zn 2 plus. Zinc to Zn 2 plus means this is the way of oxidation, that zinc is converted to the Zn 2 plus. So this line, the middle line, this indicates that this is the change of the zinc to Zn 2 plus, because it is the oxidation. So zinc is converted to the zinc 2 plus. Right hand side you have to show the reduction reaction, but obviously in the particular way. So what is the way? The way is that copper 2 plus, it is converted to the copper. So in both cases these are the single lines. Okay, I am showing you in increasing the depth of the line, but it is actually single line. But zinc to Zn 2 plus and copper 2 plus to copper, this is the particular way of the oxidation and the reduction reaction. Okay, but in the middle, you know, there is a salt bridge. I told you in the previous class that you have to connect the two chamber in case of electrochemical cell by a particular salt bridge. So double line, you have to keep in mind, this double line indicate there is an existence of the salt bridge. So you have to show the salt bridge also. In the middle line there is salt bridge, you have to show the salt bridge. Okay, so this is the particular way by which we can show the electrochemical cell. In this way we can show the electrochemical cell. This is very important. You have to keep in mind this fact that electrochemical cell, there is a particular way of the representation by which we can express the cell. Now there another question arises that I told you, or I told you in the previous class, that there may be one question may come to you in your mind, that why zinc is oxidized. That means why zinc lose the electrons and copper gain the electrons. Why not the opposite? It acts as the in opposite direction. So to explain these facts, actually, first of all, you have to know there is some term. This is called the cell potential. Okay, so cell potential is generated or cell potential is generated due to the difference of the or due to different kinds of charge which present in the surface area of the electrode. Okay, so look here, if this is any chamber, okay, and like your previous class, you know that there is a zinc sulfate solution in the chamber. Okay, so if there is zinc sulfate solution and in you dipped in this electrode, in this solution there is an electrode, there is in dipped, suppose this is the zinc rod. Okay, zinc rod is dipped into the solution. Okay, zinc rod is dipped into the solution. Okay, then what happened? Look, there are two different ions remain side by side, you know, Zn2 plus, and in the surface there is an Zn2 plus, and there is surface there is another chain. So when to define, there is a full of electrons in the electrode and there is a Zn2 plus in the side. So when these two different charges remain side by side, then what happened? One potential is developed. Okay, there is one potential is developed. One potential is developed. Okay, this is called, this type of potential is called, it is the actually electrode potential. Okay, so electrode potential. So electrode potential, again, these may be two types. Okay, there are two types of electrode potential. So what are the types of the electrode potential? So first type of electrode potential, look here, first type of electron potential, this is the oxidation potential, or it may be a reduction potential also. It may be a reduction potential also, either oxidation potential or it may be reduction potential also. Now, what is the meaning of oxidation potential and what is the meaning of reduction potential, or how we can express these two potential? Oxidation potential means it is there some oxidation reaction occur. Okay, like I am showing you, if there is the reaction is the zinc. So when zinc is converted to the Zn2 plus 2E, so there oxidation occur. So we can call this is the oxidation potential. So you can write down E Zn2 plus. Look, Zn2 plus means it is the way of the oxidation. So suppose the value of the this is the X. Okay, but when we will write down, or we can write down in the standard mode also, like E0 also. Okay, I'll discuss what is the E0, all that things. So we can express the Zn2 plus Zn. Look, this is the reduction potential, because Zn2 plus to Zn means it is a reduction potential. So then we have to write down minus X. So for each and every metal, there is a particular value of oxidation potential or reduction potential. The values are same, but the way the direction will be different for each and every metal. Okay, so this is fixed actually. There is a particular value, and where the values are mentioned, the oxidation potential or the reduction potential. Why I am telling side by side two words, oxidation potential and the reduction potential? Because the two values are same, but the sign will be different. Either it is expressed in the way of oxidation potential or it is expressed in the way of reduction potential. If oxidation potential is positive, then reduction potential will be negative. Okay, so like in the case of copper also, I can show you that if copper 2 plus to copper, then it will be reduction potential, and if copper to copper 2 plus, it will be oxidation potential. So where these values are mentioned, this is called actually electrochemical series. Okay, this is called electrochemical series. Okay, So I'll show you that what is the electrochemical series and what is the usefulness of the electrochemical series. Look here. Okay, so this is called actually electrochemical series. Okay, here all the metals like lithium, sodium, beryllium, so there are some values, A0 values are mentioned here. So normally it is mentioned in the volts. Okay, so all the values are mentioned here. So it is expressed in the way, look, lithium plus to lithium, so it is the reduction potential value. So generally we take the potential value as the reduction potential. We can express also the oxidation potential, we can express the reduction potential, but what is the general proforma? It is the reduction potential. And for that purpose, if in the exam it is not mentioned that it is which type of potential, it is generally represented as the potential of the electrode, then you have to take, if it is not mentioned, you have to take the reduction potential value. Otherwise, if it is represented in the way that lithium plus to lithium, then you can understand, okay, what is the way of direction. Lithium plus to lithium, okay, this is the reduction. If it is mentioned lithium to lithium 2 plus, it is the oxidation. Okay, so look here, all the reduction potential values are mentioned here. Okay, so if I scroll down, then look here that all the reduction potential values are mentioned here. Okay, so these values are fixed or these values are constant, where you look that hydrogen is the 0. Okay, so hydrogen has the 0. That means that generally you can keep in mind by the two ways that which will be oxidized or which will be reduced if I combine or couple the two metals of the electrochemical series. For example, if you couple here that what example we took previous class, that okay, so look here, so here is the zinc. Okay, so here is the zinc, this is the zinc. Okay, zinc 2 plus. Okay, and another there is the copper. Okay, so this is the copper 2 plus. Okay, so copper 2 plus plus copper 2e. So look here that if we take these two examples, zinc 2 plus and copper 2 plus, then clearly it is from there it is clear that which metal is in the upper position of the electrochemical series, it will be oxidized, and which will be lower position in the electrochemical series, it will be reduced. So that means in between two metals, if one metal is upper position, it will be oxidized. If you couple the two metals, like in our previous class also what you discussed about the electrochemical cell, this was the zinc copper cell. So there look, zinc was the higher position and copper was the lower position. That's why zinc was oxidized and copper was reduced. Okay, but then one question I think in your mind in this moment, that how it is possible that to keep in all the elements and keep in mind that which will be the upper position, which is the lower position. There is another way by which you can understand or you can predict which will be oxidized and which will be reduced. Okay, by the reduction potential value. Okay, so either oxidation or reduction potential value, but I think one value try to keep in mind such that it will be more helpful to you for the exam time, such that you will not be confused at any moment. Okay, so I'll show you that how you can keep in mind these values. Okay, so if I show you, so look here that generally one cell is the combination of the two chambers. Okay, so one is the oxidation chamber, another is the reduction chamber. So we can write down that E cell, okay, E is the EMF. What is the EMF? I will define. Okay, just after this discussion I will define what is the EMF. So E cell equals to, we can write down that E of anode plus E of cathode, isn't it? This is a combination of two half cell or two half chamber, E anode plus E cathode. So that equals to, anode means here oxidation or cathode, generally we are taking oxidation potential, and here reduction potential, isn't it? But what I told you that generally just keep in mind in the way of reduction potential. So if I take both the reduction potential values, there may be oxidation occur. It is not the problem that if there is oxidation occur, you can't keep the value of reduction. Okay, reduction potential value. It is not. Each and every metal has the two values. Depending on the situation, depending on the potential of other electrode, it is decided either here oxidation occur or there reduction occur. Okay, so if I express both the anode and cathode in the way of reduction potential, so we can write down at first E cathode reduction potential and then just write down here it is minus, because I am taking E anode, but it is in the way of reduction potential. So oxidation to reduction, that's why I am taking the here negative sign. Okay, so just keep in mind in this way that if you consider the or it may be E0 cell also. What is E0? I will show you. So it is E0 cell, maybe E0 anode minus E0 cathode. So just keep in mind in this way that if you consider the reduction potential for both the electrodes, then you have to keep in mind that it will be E cathode minus E anode. Okay, that means what will be the potential for cathode, you have to write down first, then you have to mention the potential of the anode. Okay, now what is the EMF? Actually, what is the written here? E, this is generally it is the EMF. Okay, EMF or electromotive force. Electromotive force. Now what is the electromotive force, or how we can define the electromotive force? Okay, so electromotive force is defined that which cause flow of electrons from one electrode to another electrode and results the flow of current. It is called the EMF. It is measured in the volts, and this force arises between the difference in potential between the two electrodes. That means this EMF is mainly responsible for the flowing of the electrons, what I told you, but this EMF it will be generated due to the difference in potential. This is the difference in potential between the two electrodes. That means if the two chambers are there but the potential of the two electrodes are same, then potential of the two electrodes, there will be no electrons, or there will be no current will be generated, or no flowing of electrons will be occur. There must be some kinds of difference of electrode potential between the two electrodes, then only we can get some kinds of flowing of electrons through the wire. So this is the EMF. Now if the EMF is measured in the standard condition, like if it is measured in the standard condition, it is represented as the standard EMF. It is represented as the E0. This is the standard EMF. Is the standard EMF. Okay, so now standard EMF means there are some conditions like solution, electrolytic solution will be 1 molar, like temperature will be 25 degrees C, etc, etc. That means there are some kinds of standard conditions are there. In this standard condition, if you measure the electrode potential EMF of the cell, then it will be the it will be the EMF of the standard EMF of the cell. So this is the EMF, okay, our standard EMF. Now we will move to the most important topic of the electrochemistry, that is the Nernst equation. Okay, so we'll discuss about the Nernst equation. Okay, so to discuss about the Nernst equation, we have to take we are taking any arbitrary reaction. Any arbitrary reaction means, for example, there A, it is any arbitrary reaction, plus B plus X plus equal to X plus Y. Any arbitrary reaction. Okay, so where this X A, B and X, Y, small a, small b, small x, small y, these are the coefficients of reactant and product respectively. Okay, so small a, small a, small b, small x, small y, these are the coefficients of reactant and product respectively. Okay, so there is no problem. But from this equation, if we want to write down the equation of Gibbs-free equation, then what will be the equation? We can write down the equation in this way, that delta G equals to delta G, that equals to delta G0 plus RT ln concentration of product, that means concentration of X, concentration of reactant Y, power X power Y, concentration of A and concentration of B. Okay, so look here, there is some kinds of equation of the Gibbs. This is the equation of Gibbs free energy, and you know that in according to the Gibbs free energy, this is the change of Gibbs free energy. Okay, change of Gibbs free energy. This is the change of standard Gibbs free energy, and in the upper side there will be the concentration of the products, and in the power there will be the coefficients of the each and every product, and in the lower side there will be the concentration of the reactants, in power their coefficients. Okay, but you know that delta G equals to it will be delta G equals to minus NFE. Okay, this you have to keep in mind, and this is the relationship between thermodynamics and the electrochemistry, you know, because with the Gibbs free energy we can establish the relation delta G equals to NFE. What is the N? N is the number, you have to keep in mind, number of change of electrons, in the reaction. You have to keep in mind. Okay, what is the F? F is the farad, and you know 1 farad equal to 96500 coulomb. Okay, so 96500 coulomb. And NFE, what is the E? E is the EMF of the cell. Okay, is the EMF of the cell. So this is, you have to keep in mind, and in the same way we can write down that delta Z0, that equals to minus NFE0, where delta Z0 is the change of standard Gibbs free energy, and E0 is the it is the standard EMF of the cell. Okay, now if you put the expression of the delta G equals to minus NFE, then what you will find out? You will find out the equation will be that in place of delta G we are putting here minus NFE, so minus NFE, that equals to minus NFE0 plus RT ln. What was the previous case? It was the same, concentration of product by concentration of reactant. Okay, but now we'll move to the RT ln to log. So what we have to do, if I convert RT ln to log, then what we have to multiply with 2.303, isn't it? So then we have to multiply the 2.303, and NF is the common factor, so we are taking the common. So here, from here we can write down that E is equal to E0 minus 2.303 into RT by NF log. Then what was the upper product and lower product? That will be the same. Okay, there is no change. So but what change occurred here? So minus NF, this is the common factor, so minus NF is the common, and that's why the plus sign here, plus sign become the negative sign, because minus NF is the common factor. And E equals to E0 minus 2.303 to conversion of the ln to log. Okay, so this is the for conversion you have to multiply with 2.303. so this is for the conversion purpose we have to multiply with 2.303. now look here that if I consider that 2.303, you know, R, universal gas constant, temperature, and a farad, these all are the constant, isn't it? N can vary because N is the number of electrons involved in the reaction, so N can be changed. But other than N, all the other terms are constant here. R, T, 2.303 F, and if we take the values of these things, then the Nernst equation become this E is equal to E0 minus 0.059. This is the value of the constant. If I add all the constant values, then we'll get the 0.059 divided by n log of concentration of product, that was the concentration of x to the power x, and concentration of y to the power y, and concentration of the reactant. Okay, and this is the final form of the Nernst equation. You have to keep in mind E equals to E0 minus 0.059 by n log of concentration of product by concentration of reactant. You have to keep in mind this equation very carefully, because this is very, very important for your exam purpose. So finally, you have to keep in mind some equations for solving the numerical problems. I'll show you also one numerical problem. So first of all, you have to keep in mind that delta G equals to minus NFE, or delta G0 equals to minus NFE0. You have to keep in mind. You have to keep in mind E0 cell. Okay, that means standard EMF of the cell, that equals to 0.0591 by n log of K. K is the rate constant. Okay, K is the rate constant, and W, that means the work done, W equals to only NFE. Okay, you have to keep in mind NFE0. Okay, so W equals to NFE0. You have to keep in mind this, all the things in your mind. Okay, so because this is very much required for the numerical problem purpose. Okay, that I will show you that one numerical problem, that how you can use these all the values for your numerical problem purpose. For example, in your question paper, it is mentioned in your question paper that E0 AG plus AG, that equals to 0.799, and E0 Cu2 plus 2Cu, this value given as the 0.337. okay, so volt. So for example, you have to find out that what will be the full reaction, that means what will be the cell reaction. First of all, you have to find out E0 cell, or if the concentration is mentioned, then you have to find out the E cell also. Okay, so for this purpose, what you have to do, you have to first understand that where oxidation occur, where reduction occur. Okay, because in this case the potential values are given. Suppose you forget that what is the situation or position of the silver and what is the position of the copper, then what you will do? I can give you one tricks for this purpose. Just keep in mind these tricks, then you will understand that where oxidation occur, where reduction occur, because this is the first thing which you have to understand. Otherwise, you will be not able to solve the problem. Okay. So what is this tricks? Tricks is the which have the lower reduction potential, in between these two, it reduces other and self oxidized. I will explain also self oxidized. Okay, so that means, what is the meaning of the word? In between these two metal, what values are given in the question, in between these two metals which have the lower reduction potential, it reduces other. So first of all, you have to check either it is a reduction potential or not. So check it. Okay, either it is a reduction potential or not. So if you check it, then you will find out that Ag plus to Ag, this is the reduction reaction, because Ag plus E, it is taking the electron, and for the conversion of Ag, so obviously Ag plus to Ag, this is the reduction reaction obviously, and copper 2 plus copper, it is also reduction reaction. So that means both are expressed in the way of reduction potential. Now check which have the lower reduction potential, 0.799 and 0.333. Which have the lower reduction potential? Obviously this is the lower reduction potential. So copper has the lower reduction potential. So according to what I told in the statement, copper has the lower reduction potential. So copper reduces silver. So here reduction occur, reduces silver, and copper will be self oxidized. So copper will be self oxidized and silver will be reduced. First of all, understand this fact, because In case of copper, there is a lower reduction potential value, so it reduces other, that means silver will be reduced and copper will be oxidized. Is it clear? Okay. Now if copper will be oxidized, just write down the reaction of the oxidation reaction of the copper. So what will be the oxidation reaction of the copper? Just write down. So copper oxidation reaction, copper 2 plus 2E, simple case, because this is the oxidation reaction, so copper will lose the electrons, okay, and silver will be reduced, so simple, silver, that means Ag plus E, it is converted to Ag, simple case, okay. Now look, their change of electrons will be equal, otherwise how you can find out the n value? Number of electrons will be same. So to make this point that change of electrons will be same, just multiply with this equation with 2, okay, then change of electrons will be same, isn't it? So then you can write down the full reaction, that Cu plus 2 Ag plus this is converted to Cu2 plus 2 Ag, okay. So Cu plus 2 Ag plus to Cu2 plus 2 Ag, simple. This is the full reaction. Now what you have to do, you have to find out E0 cell. So when you are trying to find out the E0 cell, then you have the equation that E0 cathode minus E0 anode. You have the equation because we are considering the reduction potential for the both cases. So what is the value of cathode? Cathode means which electrode acts as the cathode where reduction occur. Where reduction occur? Reduction occur in case of silver electrode, isn't it? So what is the potential of the silver electrode? It is given in the question paper. The potential of silver electrode is 0. What is the potential given? This is the 0.80, I think, okay. So if it is the 0.79, okay, so if it is 0.79, then just write down 0.79 minus 0.79 minus what is the value of copper? This acts as a oxidant or anode. So here this acts as a 0.79 minus 0.33. So the value will be 0.462 volt. Okay, keep in mind, if the E0 value you are getting the positive, that indicates that your cell is right, there will be flowing of electrons. If you get the E0 value negative, that's a little bit problem, okay. So it's right, you are getting the positive value, and this is the E0 value actually. So this is the E0 value, this is the E0 value, E0 of the cell you are getting. Now you can do all the things, okay, all the other things. If you know the E0 value, you can find out the delta G, because delta G equals to minus NFE, N equal to 2, F is equal to 96500 coulomb. You can understand easily. You can calculate the work done, and also you can calculate the Nernst equation from the you can apply the Nernst equation also to find out E cell, because E cell equals to, in this case, E cell equal to E0 cell, which you know already. E0 cell minus 0.059 divided by 2 log of concentration of the product. Product means what was the reaction. In the reaction product, there are the two products. One product was the copper 2 plus, another was the silver, but you have to write down only copper 2 plus, because generally the concentration of the pure metal, that means Ag, that is taken as the 1. Okay, so it will be only concentration of copper 2 plus divided by concentration of Ag plus, but in case of Ag plus it will be 2, because the coefficient of the Ag plus was the what is the coefficient of Ag plus? This was the 2. That's why here it will be 2. Now if the question arises in this way, that any of the values are given, if in the question paper, if any of the values are given, for example the concentration of the Cu2 plus, this is given, so you have to find out the concentration of Ag plus from this equation, because there at that time E cell value will be provided. E0 cell you can calculate, you know all the other values, okay. In this process, by applying this process, you can easily calculate what will be the value of the concentration value or the E cell value from the Nernst equation, okay. So just keep in mind all that things, because this is very, very important for solving the numerical problem, okay. And you can use this equation for another purpose also, okay. So, and on other thing you have to keep in mind, for solid metal or for pure metal like silver, like copper, these the concentration value is taken normally say 1. Okay, that's why you want me to hear the concentration of Ag or concentration of Cu. Okay, so that's all for today. and this all for also module 2 what we discussed. Okay, and just you have to read all the things carefully which I discussed, starting from thermodynamics part, starting from electrochemistry part. Okay, and thanks for watching, and meet with you in the next class with a different topic. Goodbye.